Lesson 23E, converting measurements. And of course, I'm going to have links in the description to help you. So check them out if you need them. And I've talked about this before. They're going to give you a sheet of paper before the GED test that's going to have the formulas on it. And this is the one from the book. And it tells you the formulas for area, perimeter, the circumference of a circle, the volume. Okay, so they're going to give this to you, and you don't need to memorize these. You just need to know how to identify which one's which and which one you need to use. Okay, and sometimes we're going to get a diagram for a problem, and the measurements will be in different increments. This is 2 inches high, 3 inches wide, but a foot long. And if the answer is in cubic inches, we need to convert that 1 foot to 12 inches. We'll need to use the conversion factor ratios to change one unit of measure to another. So 12 inches is 1 foot. So for length times width times height to find the volume of this, we're going to do 2 inches times 3 inches times 12 inches. See? Or 12 times 3 times 2, same thing. And then we'll get the cubic volume. Okay? We need to make sure that all the units of measure are the same as each other. And what is the volume in cubic inches of the rectangular solid? Well, it wants the answer in cubic inches, but that says 2 feet and 3 feet. So if 1 foot is 12 inches, then 2 feet is 24 inches. See, that's the conversion ratio. If 1 foot is 12 inches, then 3 feet is 36 inches. We plug those in to our length times width times height. We check our sheet. We look for volume of a rectangular container. It's length times width times height. See that? So for every problem, you're probably going to have to look at this sheet. No big deal, okay? We do 36 times 6 times 24 and get 5,184 cubic inches, or inches cubed. See? It's volume, so we've got the little 3 exponent, don't we? Now, what if it wanted all the answers to be in feet? Well, then we'd have to convert that to feet, and 6 inches is half foot. So we would do 3 times 0.5 times 2, and we'd get 3 cubic feet. 0.5 times 2 is 1, so 3 times 1 is 3. It would be 3 feet cubed. See? So we do the conversion before we start doing the math, okay? What is the perimeter of the triangle in feet? Well, it gives us inches. And perimeter is the measure of the outside area, so we need to do 26 plus 26 plus 26, or 3 times 26, which is 78 inches. Now we need to put it into feet. We can divide 78 by 12. We get 6.5, because there's 12 inches in a foot. So we have 6.5 feet. See? We did what they asked. What is the area of the triangle in square inches? Well, we need to do area equals half base height. We look on our sheet for area of a triangle, and we find out that its area equals half base height. So we have our height, 6 inches, but that says 1.5 feet, and it wants the answer in inches. 1.5 feet is 18 inches. It's 1 foot and a half foot. See? So really, it would be like this, wouldn't it? So we're going to do half times 6 times 18, see? And when we have a unit fraction where there's a 1 as a numerator, that's a unit fraction, we can just divide by the denominator. That gives us 0.5 times 108 if we want to do it that way for the half, or we could just do 108 divided by 2 and get 54 inches squared, or square inches, okay? So do the conversion before you do the math. What is the area of the triangle in square centimeters? Well, this one says that the base is 2 meters. And we can, if you remember, there's 100 centimeters in a meter. So really, if this is 75 centimeters tall, then we've got 200 centimeters as the base. Now we can do half times 200 times 75. You can do half times 200, which is 100. Times 75 is 7,500, or you can multiply these first. It doesn't matter in multiplication, right? We get 7,500 square centimeters. You can multiply it by 0.5, or you can just, because it's a unit fraction, we can just divide it by 2. See? Which expression will find the volume of the cylinder in cubic inches? So now we need the volume of a cylinder. And we look on our sheet, and we see that that's the formula for volume of a cylinder. Pi is 3.14. Well, they all start with that. The radius squared, well, the radius is 6 inches, so we need 6 squared. So it's either number 2 or number 3. And then in inches, 2.5 feet would be 24 is 2 feet, and 6 is half a foot, so that would be 30 inches. So number 3 would be the correct one, see? So you're going to have to check the sheet again to find the formula, and then figure out which one fits it, see? A cone has a height of 1 3/4 feet and a base with an area of 78.5 square inches. What is the volume in cubic inches? So we have to convert that to inches. So the first thing we're going to do before we look for the formula is convert that to inches. And 1 foot is 12 inches. 3/4 of a foot is 9 inches. That's 21 inches. So now we know the height is 21 inches. Now, this pi r squared in red here, that's the area of the base. So it might show up like that on this sheet. It'll say, because we're doing the volume of a cone, it'll say 1/3 times radius squared. See? Times pi times radius squared. Can you see that? Well, that's the area of the base, that pi radius squared. See? The area of a circle is pi times the radius squared. See? So you really don't need to do that in this case. Do you know why? They're giving you the base area of 78.5 square inches. So really, all we need is V equals 1/3 AH for area of the base. See? So watch out for tricky questions like this where it's already giving you the area of the base so that you don't do it again, okay? Just remember that that pi r squared is the area of a circle. So now we can do 1/3 times 78.5, the area of that base, times the 21 inches in height. Here we have another unit fraction, so instead of multiplying it by 1/3, which would be on our calculator as a decimal, 0.3333, and it's not really accurate, so it's better to just divide it by 3. It's got a 1 as a denominator, we can divide it by 3. We get 549.5 cubic inches, okay? What is the approximate volume in cubic feet? And it wants approximate volume of a box that is 3 1/4 feet long, 2 feet 9 inches wide, and 2 feet 6 inches tall. It wants it in feet. So what we can do is say, well, 3 1/4 would be 3.25, wouldn't it? 2 feet 9 inches, we know that 9 inches is 3/4 of a foot. 3/4 would be 0.75, wouldn't it? So that would be 2.75 feet. 2 feet 6 inches tall would be 2.5 feet, because 6 inches is half of a foot. So now we've got them like this in decimals, and they're all in feet. Now we can look on our sheet for the volume of a box or a rectangular solid, whatever it says on the sheet, volume of a box, and we get volume equals length times width times height, so we can just multiply these together. We're going to get this nice long decimal, but it wants it in approximate volume in cubic feet. So it doesn't want this answer. It's going to want 22 cubic feet because that 3 tells the 2 to stay the same, and then when it's done doing its job, it disappears, right? So it's approximately 22 cubic feet. All right? All right, I wanted to show you these because these could trip you up. Look at this. We have a bunch of circles within circles, don't we? So from this point to this point is 6 feet. That's the radius, okay? And then it's saying that ring is 18 inches and this ring is 18 inches. What is the circumference of this circle to the nearest foot? So we look on our sheet for the circumference of a circle, and it tells us that we need pi times the diameter. So we need pi times the diameter. Well, what's the diameter? Well, the radius is right here. That's half the diameter. The diameter is the length from this edge of this blue circle all the way across. And if this is 18 inches and this is 18 inches, you have to remember that we have to add 18 and 18 on the other side to go all the way across, okay? If that's 18 inches wide, that's just right here, and that's 18. That means that's 18 and that's 18, so that's kind of tricky, isn't it? So to find the radius, we could take half of the 6 feet, which is 3 feet, and then add the 18 inches and 18 inches, which would be 3 feet, and we'd have a radius of 6 feet. But for its diameter, we would have to do this 18 times 4, see, to go all the way across with that center measure of 6 feet to get a 12-foot diameter. So we would do pi times 12, and it says it wants it to the nearest foot, so that's not the answer. We have to round this. The 6 tells the 7 to go up to an 8, so it rounds to 38 feet, see? You'll even come across problems with rectangles like that where it'll tell you that that's 10 inches, that's 50 inches, or whatever the numbers are. You have to remember that that means that's 10 inches, okay? And if it's perfectly drawn where it's the same distance all the way around, the same width all the way around, that means that's 10 inches and that's 10 inches, see? So it can be very tricky, all right? Now this one was kind of important because there were lots of steps to this. So we've been talking about converting it to the measures that they want first and then doing the math. So here we've got a concrete slab and it costs $90 per cubic yard for concrete plus a $60 per load delivery fee. So for the concrete truck to come out and for the guy to pour this concrete, it's $90 per cubic yard plus $60 delivery fee. How much would it cost for this 12-foot by 12-foot slab that's 6 inches thick? So we get a bunch of different choices of equations. Which equation would find the total cost for the concrete slab in the diagram? We look at all of these different ones. So what we need to do is figure it out and then see how we figured it out and which one worked. So the first thing we're going to do is convert the measures to cubic yards because the price was in cubic yards, but this is in feet. And there's 3 feet in 1 yard, so that's 4 yards, and that's 4 yards, okay? So now we have 4 yards times 4 yards. Now, it was 6 inches thick, and 1 yard is 3 feet, 6 inches is half a yard. That means there's going to be 1/6 of a yard for the 6 inches. That 6-inch thickness is 1/6 of a yard. It's also half of a foot, okay? And you have to keep in mind that a cubic yard measures 1 yard in length, width, and height. So that's 3 feet times 3 feet times 3 feet. See? That's 27 cubic feet. So now we've got 4 times 4 times 1/6 for length, width, and height in yards. And remember, because that's a unit fraction, we can just divide it by 6. So instead of taking 4 times 4, which is 16, and multiplying it by 1/6, because it's got a 1 as a numerator, we can just divide the whole thing by 6. We can do 16 divided by 6. So the correct answer would be number 3. It would be 4 squared divided by 6. You multiply it by the $90 per cubic yard, and then you add that $60 fee. And it'd be a little over $300. So number 3 would be the correct answer. Now look at this one. Number 2 could be confusing. It's got 12 squared, which is 12 times 12, and then it's got times 0.5. Well, 0.5 is half of a foot. So it looks like that might work, and then they're multiplying it by the $90 per cubic yard and then adding the $60. But look, they're dividing it by 3. And the reason this one is wrong is because we wouldn't divide it by 3. We would divide it by 27 because there's 27 cubic feet in a cubic yard. We would find the total volume in cubic feet, then convert it to cubic yards. See, this way, we converted everything to yards first and then solved it. If we just found it in cubic feet and then did all the math and then converted it to cubic yards, we would do 12 times 12 times 0.5 for the half foot, right? So that would be 144 times 0.5. That would be 72 cubic feet. Now we need to turn it into cubic yards. Now, if we've got 72 cubic feet and there's 27 cubic feet per cubic yard, we need to divide that by 27. And we get this nice long decimal that rounds to approximately 2.67, which is what happened down here. 16 divided by 6 is 2.67 approximately. So if the equation was divided by 27, then it would have been right, but it's not. It's divided by 3, so it's wrong. So see how tricky that is? You're going to think, oh, there's 3 feet in a yard. I bet that one's the right answer, when actually it's not. There's 27 cubic feet, all right, to a cubic yard. So be very, very careful, all right? I think there's a problem that's similar to this in one of the actual tests in the back of the book. But you should now be ready to do the skill focus on page 283, and it might even seem easy. Just use that formula sheet that's in the book and keep your eyes open for different units of measure. Our next lesson is going to be solving for variables in formula. And we've talked about this before, where you can take a formula and solve it for a different letter in the formula than what it's showing. If it says V equals, we could solve this for H and make it H equals. So we're going to talk about that some more. And there's going to be links in the description where back in video 14b in this GED playlist, we talked about the conversion factors and the ratios converting measures, and then I'll have links to the previous videos for this lesson 23 that we've been doing, okay? So we're still in lesson 23 because we're going to be doing solving for the variables and formulas coming up next, 23F, okay? So we're almost done with lesson 23. We'll be moving on to lesson 24, so make sure you understand all of this before you move on. And like I always say, I hope you have a great day. Keep trying, and I'll see you next time. Bye.